So what are the complementary angles? Now complementary angles, these are the angles add up to 90 degrees. And let's say we have the actual angle said to be 90 degrees. Let's say this is the case. And assuming that we have, let's say, angle A, and we have, let's say, angle B. Now angle A as well as the angle B are said to be a complementary angles because they are sharing the angle sum of 90 degrees. Hence, angle A as well as the angle B are said to be complementary angles. In this case, you should have to understand that the value of the angle A plus the value of the angle B, it is the same as 90 degrees. The reason behind being the complementary angles. Let's say we have this case. Assuming that we have let's say the value of, let's say, 25 should be a 50 degrees. Let's say this is a 50 degrees angle. That should be that. Let's say this is the angle value x. What is the value of the angle x? So now in this case, these angles are said to be complementary angles. In this case, we have angle x and plus 50 degrees, and that will be equal to 90 degrees. So the reason being complementary angles. So which means the angle x will be given as 90 minus 50. That will be equal to x being given as 40 degrees. So that's the principle behind the complementary angles. And let's say we have, in this case, assuming that we have, let's say this case as well, and let's say we have 2x let's say 2x plus 1, let's say this is 5x, let's say minus 2, let's say this is a, let's say this is b, and c, let's say this is the value, actually this is the d. Now find the actually angle labeled ABC as well as the angle labeled actually CBD. In other words, we should have the value of angle this, actually angle this one, and also the value of this angle. Now how should you have the values of this angle? In this case, we should have to first of all calculate the value of actually x, in the sense that we have to sum this and also sum this equal to 90 degrees because they are actually complementary angles. So try to have that at your own actually space. So the point of interest is that we should have to look at the actually a sine and a cosine properties of the complementary angles. Let's consider this case. Let's say we have the Cartesian plane. Let's say this is the case, and assuming that we have, let's say, a right angled triangle. Let's say it should go like this, and we have it in this way. Let's say this is 90 degrees, and let's say this is A, let's say this is B, in that way. Then of course, let's say this is angle theta, we may just have this first. Let's say this is a side B, that is hypotenuse, of course. And now let's also think of connecting this. And for this case, if this is actually a side A, it means this is also a side A, because let's say this is actually a rectangle, the opposite sides are equal, and of which what we have is also that of rectangular triangle, and it corresponds actually and corresponding to the same actually hypotenuse. Now this is the angle theta, of which what is the value of this angle? Now this angle and this angle are complementary angles, in the sense that, let's say in this case, it means we'll have it as 90 minus angle theta. That is the value of this angle, because they are complementary angles. So keep that in mind. So now, using this angle theta with respect to this side and the hypotenuse, what are I having? So you can see that we have opposite and hypotenuse. That is actually a sine of angle theta is equal to A over B. That is, and also let's have this 90 degree minus theta with respect to the adjacent as well as the hypotenuse. So what is that? We have it as a cos of 90 degree minus theta is equal to that of, that is A of B, as you can see. Now at the end of the day, you should have to understand that the sin theta is equal to A of B, and the cos of 90 degree minus theta, it is the same as A actually of B. In other words, you can see that a sine of angle theta, it is the same as the cos of the complement of the angle theta, as you can see, because this angle and this angle are complementary angles. So which means the sine of angle theta, it is the same as the cos of the complement of this angle, which is 90 minus theta. So in this case, we'll have it as a sin theta is the same as cos of 90 degrees minus theta. We'll have that, by the way. Let me take it back. So which means we'll have it as a sin theta is the same as, should be cos of 90 minus theta. And also this is true if we can have, let's say, a cos of, let's say, theta, it is the same as the sine of should be 90 minus angle actually theta. This is one of the properties of the complementary angles, and this is also true if we may think of having this, and this is all true. This is also true if even we can have this. It will be the same. Let's say we have even we have it in this case. Let's say this is the case. And assuming that this is angle A, then let's say this is the angle B. And should be that this is M and let's say this is A in that way. This is Ladang the triangle, and this is also Ladang the triangle. If this is M, it means this is also the value of M. It means that side is also said to be M. So at the end of the day, this is angle theta A, and this is opposite, and this is hypotenuse, of which we have it as a sine. So which means a sine of actually angle A is equal to M over N. And let's say a value of B, you know, you have to understand that the value of B, it is the complement of the angle A. In other words, those angles are complementary angles. So which means we have the adjacent and the hypotenuse. That is for angle B. That will be given as, now that will be given as, that is cos B, which is equal to M over N. At the end of the day, you see that provided A and B are complementary angles, then sine of angle A, it is the same as the cos of angle actually A. And likewise it's true, even if we can have, let's say, sine of angle theta 1, it is the same as the cos of, let's say, angle theta 2, provided these angles are complementary angles. Likewise, the cos of angle theta 2 is the same as the sine of angle theta. So those are the properties of the complementary actually angles. Now, you need to keep this in mind about the properties. Provided the angle A and the angle B are complementary angles, then this is true. Sine of angle A, it is the same as cos of angle A. And let's say the cos of, let's say, should be angle B. So it is the same as cos of angle B. Likewise, cos of angle A, it is the same as the sine of angle B. That is provided the angle A as well as the B are complementary angles. You should keep that in mind. And also in the same case, you should have to understand that the cos of, let's say, angle theta, it is the same as the sine of actually 90 minus angle theta. In other words, these angles are complementary angles. And also in the same case, you keep in mind that having, let's say, a sine of angle theta, it is the same as cos of 90 degrees minus angle theta. That is the same as that. And on the same case, we know that the tan, and also we know that the tan, it is the same as, you know, it is the same as sin theta, should be a tan theta. It is the same as, you know, a sin theta over cos theta. It is the same as that. And also on the same case, which means a tan of, let's say, which means we can also be able to have this one as well, which means if we have, let's say, a tan of, let's say, a tan of 90 degrees minus the angle theta, it is the same as the sine of 90 degrees minus angle theta divided by cos of 90 minus angle theta. That would be the same as that, because we know that the tan theta is the same as a sin theta of cos theta, of which this angle is the same as this, it is the same as that. So those are the properties you keep in mind. Now let's try to evaluate the following, and using the properties of the complementary angles. Now let's think of solving the following cases. Now solve the following equation. Let's say we have a sine x and is equal to, let's say, cos of angle actually 37. So now what is the value of x if this is the case? Now you should keep in mind that x and 37 are complementary acute angles, in the sense that if we have angle x and plus 37, you know it is the same as 90 degrees. So which means we'll have it as angle x being equal to 90 degrees and minus 37 degrees. So you'll be able to have the value of x there. And how about if we have, let's say, this case? Let's say we have the cos of, let's say, 2x, and that should be is equal to, and that should be sine, let's say, 50. Now what is the value of x in this case? So 2x is the angle of cos. This is the angle corresponding to cos. So these two angles are complementary angles, in the sense that we have 2x and plus 50, that is equal to 90. Then you'll be able to solve for x in this case. And how about, let's say, if we have this case? Let's say if we have, now let's say if we have this, let's say we have a sine 3x, let's say is equal to, should be cos of, let's say, angle x plus, let's say, 20. Let's say this is the case. Now we have angle 3x and the whole entire angle x plus 20. What is the value of x in this case? So these two angles are complementary angles, in the sense that we have 3x and the plus x and the plus 20, that is equal to 90 degrees. Then you'll be able to solve x there. And also think about this one also. Let's say if we have, that should be a sine of, let's say, angle 2x plus 40 degrees, and which is equal to, let's say, have cos of let's say 3x and plus should be 20. Let's say this is the case. What is the value of actually what is the value of x in this case? So these two angles, this angle and this angle, are complementary angles. So have 2x plus 40 is equal, now should be plus 40 and the plus 3x and the plus 20 will be equal to 90. Then I solve for x there. And let's think of having this case as well, and appreciate how best we can go over that. Let's say we have sine. Let's say we have sine of y square, let's say, is equal to cos of, let's say, 26 degrees. Now what is the value of the y? In other words, how should you solve for y in this case? So principle remains the same. Y square is the angle and 26 is the angle. And these angles are complementary angles, in the sense that we have y square and a plus 26, and which is equal to 90. Then you'll be able to solve y in that way. And of course you even see that you have it as y square is equal to 90 minus 26. Then you subtract here, you have, and you square both sides, you have everything here. So you have two values of x, should be two values of y. So keep that in mind. Let's say we have, now you have to try this at your own time. Let's say we have cos y is equal to, let's say, sine y. What is the value of y? And let's say we have, should be cos of, let's say, 3x minus 30. My pen is it's misbehaving. That is equal to, let's say, have a sine of 7x and that plus 50. Now try to solve for actually x in that way. And also try this one as well. That is we have cos 2y is equal to sine 3y. What is the value of y in that thing? So that's how we should have to understand about the sine as well as the cosine properties, and for the actually complementary angles. Thank you.